Good evening, students.
Good evening, ma'am.
No one has come as of now, Ananya? Or who
Yes,
is
ma'am.
there?
They haven't come yet.
Okay. Let's wait for 3-4 minutes or we'll start the class. Do you have any doubts?
No, ma'am.
Okay. You can see the screen, Ananya.
Yes,
What's your-
ma'am.
Yes, ma'am, I can see the screen.
Hmm?
Yes, ma'am, I can see the screen.
Okay.
बहुत बहुत प्यारे लग रहे हैं ये ऐसे पप्पलू। हेलो एवरीवन, कैसे हैं आप? आई होप आप अपने घर में बिल्कुल सही होंगे। वेलकम टू दोस्तों, काजोल की सेपरेशन के बाद वो इसमें काफी डिस्टर्ब नजर।
Hindi தெரியாது. Ma'am, can you hear me?
Good evening. So all of you have settled down?
Yes, ma'am.
Okay. So let's begin it
Ma'am.
from there.
Ma'am, there's still 2 more to come to the tuition.
2 more to come. Let's wait for two students, 2 minutes. 17:19 by my watch. Let's wait till 17:21. So it's 17:21. Let's start the class. We cannot afford to wait more for the students. Or do you have any idea whether they are coming or not?
Ma'am, no, ma'am.
Okay, so let's begin. So in the last class, we discussed about the empirical formula and how to find the empirical formula from the percentages given, right? Now, the next thing which we have to understand how to find the molecular formula. For finding the molecular formula, it is important to know this particular formula. Because molecular formula is N into empirical formula. N will be equal to molecular mass upon empirical formula mass. So whenever somebody wants you to find the molecular mass, the examiner must be giving you the molecular mass. Is it clear?
Yes, ma'am.
Okay. So if this is a solved example for you, since it was you can do it orally, hydrogen peroxide and hydrogen peroxide we have discussed many times in the class. So we know what is the N for it, right? Empirical formula mass is 17 and molecular formula mass is molecular mass is 34. So the value of N will come out as 2. I hope it should be easy and clear to all of you. So if somebody wants me to tell the molecular formula of it, I will simply multiply by N. So we have two formulas. The first formula was how to get N. And then molecular formula is equal to N into empirical formula. Have you already done it in your class, in normal school classes?
Yes, ma'am.
Okay. So then quickly do this question. The molecular formula of compound is C8H6O4 and its empirical formula mass is 83. Calculate the empirical formula of the compound. Is the question clear to all of you?
Yes, ma'am. Very clear.
Okay. Have you calculated the molecular formula or the molecular mass of C8H6O4?
I'm on the way, ma'am.
Okay.
Ma'am, I found the answer.
Yeah, what is it?
Ma'am, C4H3O2.
Okay. What about rest of the class?
Ma'am, everyone got the same answer.
Good. So that seems to be pretty easy. But suppose they have not given you neither N nor empirical formula mass. In that case, do you know what do they give? Any idea? I don't
Ma'am?
want to give you the, see, I want to give you a numerical, but I don't want to tell you the molecular formula. Or I don't want to give you the molecular mass. In that case, what data should I be giving it to you so that you can reach to the answer?
We're not sure.
What is your uncertain answer if you are not so sure?
Ma'am, the molecular mass.
That's what I'm saying. I don't want to tell you neither the molecular formula. I want to give you, see, I want to ask a question about, let's say, methane. Right? I'm asking you to calculate, to find the empirical formula of methane, right? Or ethene. But I don't want to tell you that ethene is C2H4. And neither I want to tell you that its molecular mass will be 12 into 2 plus 2 into 2 into 4. I don't want to tell you that. In that case, what is the data which as an examiner somebody should give you?
An empirical formula.
No. The answer which I was looking for, vapor density. Sometimes they don't give you the molecular formula. Instead, they give you vapor density, right? So with the help of vapor density, you can find the molecular formula. See, the statement of the question can be that the molecular formula, the vapor density of a compound was found to be, let's say, 66. And rest of the question, like percentage of carbon, nitrogen, whatever it has is given as it is. It's a very small and useful formula. Since you people were asking so frequently to tell you about molarity, which is actually not in school, in the CBSE class 11 syllabus as of now. So I thought this must be a useful tip for you to do the question. Is it clear?
Yes, ma'am.
Okay. Now, this is an interesting question. If you can you tell me what is special about this question? Have you heard about the hydrated and unhydrated salts?
No, ma'am.
Okay. What about the class 10th chapter, acid, bases, and salts? Hygroscopic, I believe, FeSO4.7 water, CuSO4.5 water. There were
Yes.
gypsum. So what is hydrated and what is anhydrous?
Ma'am, hydrated salt has water like hidden inside it. Like water of crystallization.
Do we use the term hidden? This will be more scientific.
Huh?
What do you mean by hidden?
Like water of crystallization, it's not actually wet, but the water for the molecule is there in like a crystal form.
I'll not take that. Let me explain it to you. There are certain salts which when they crystallize. See, pure substance, sugar is what? It is crystalline form of cane sugar. Cane sugar is a solution. I'm not sure if you have seen crystallization at your home. When your mom cooks some certain, say, Mysore pak or some sweet of that particular variety. Have you done crystallization activity at home?
Yes, ma'am.
What happens during that? Can anyone explain it to me? Okay, I will make a video for crystallization someday on copper sulfate or any other compound and let you know. Let's not go into those details, otherwise we'll not be still able to catch up with the concepts which we have to cover. See, what hydrated means when they were crystallizing. Since you have not heard, some of you, if you have reached to, say, chapter 3rd, where you have been taught about d block elements, where we say they have vacant d orbitals, in which an special type of a bond is formed, which is called as coordinate bond. Have you heard about them? Anyone?
Yes, ma'am.
What is that then? for the benefit of rest of the students, we say it is a special case of covalent bond. Quickly, I'll tell you, covalent bond is formed by sharing of a pair of electrons in which each of the atom contributes one electron each, right? But in coordinate bond, both the electrons are being given by the same element. If I talk about FeSO4, in iron is a d block element. It has a vacant spaces. Just assume that. Water has at oxygen lone pair of electron. I believe you are clear about the term. What is a lone pair of electron? Any idea?
Can you repeat the question?
What is a lone pair of electron?
I'm an electron which is like alone at the edge of the atom.
See, if I talk about
Balance
nitrogen, the in case of ammonia, how many electrons are there in the valence shell of nitrogen? See, atomic number of nitrogen is 7. And its configuration is 2, 5 in terms of orbits. In terms of orbitals, if you know, it is 1s2, 2s2, 2p, 3. Right? In case of ammonia, it has a lone pair of electron. So what is a lone pair of electron? For those who do not understand the orbital configurations, I'll tell that there are 5 electrons.
Please explain this stuff again, ma'am.
What?
The lone pair of electrons.
That is what I'm coming to.
Okay, ma'am.
That is what I'm, see, there is a lot of history involved with it, or your certain, see, I believe, is everyone clear about the orbital configuration? Although I have not taught you. Can you write the orbital configuration of nitrogen?
No, ma'am. Ma'am, can you like
Okay.
explain again? Like
Okay,
again?
I will, so, okay. Just then, we will be focusing on this 2, 5. We will not be discussing this 2, right? We
Yes,
know
ma'am.
the formula of a compound named as ammonia, right? In ammonia, we have understood that there are total of 5 electrons in valence shell of nitrogen, right? So what we can say, nitrogen forms one bond, covalent bond with one hydrogen, another covalent bond with another hydrogen, and the third covalent bond with another hydrogen. That means 5 electrons are present in valence shell. Out of that, 3 are forming bonds, right? The remaining 2 are still present in valence shell, but no, they are not forming bond. They are known as lone pair. Is it clear now?
Yes, ma'am.
You can write the definition as this is a pair of electrons which is present in valence shell but does not take part in bond formation or does not form bond. Clear? And I'll
Lone bond.
appreciate, they are called as simply, they do not form, they are called as lone pair of electrons. Lone means akele, that is, they do not have a companion. This is the term. The valence shell can have two types of electron. One is called as bond pair, which is forming the bond, right? So what we can say, this has 5 electrons. Out of that, 3 are bond pair, and rest of the 2 are lone pair. Is the terminology clear to everyone now?
Yes, ma'am, clear, ma'am.
Okay. So what I was trying to tell you, how the water of hydration or how the hydrated compounds are formed. So in that case, what happens? We must remember the atomic number of oxygen is, what is the atomic number of oxygen?
Yes.
No idea? Atomic number of oxygen is 8. It has
Ma'am,
6 electrons.
Ma'am, 8.
Okay. It has 6 electrons in valence shell, right? Now you can, if you draw the structure of water, what happens? Out of 6 electrons, these 6, 2 are forming bonds. It still has 4 electrons not forming bond, right?
Yes, ma'am.
That means, what does it have? It has, I say they have 2 lone pair of electrons, right? 4 electron means 2 pairs. So which are represented by the dots like this. 1 dot, 2 dot, and then this is the 3rd dot and 4th dot, right? So in case of the crystalline compounds, when the crystals are being formed, these lone pairs are donated to the metal. Like if I say I have FeSO4.7 water. So what happens? You can imagine that 2 iron atom, this is our iron atom. Isme kya hoga? What will happen here? That the oxygen atom of water will donate their lone pair of electron and form a coordinate bond. Is it clear now?
Yes, ma'am.
So through coordinate bond, it's not, they are just, I believe you were having a feeling they are just fitted inside it. No, there is a bond formation, right? So, and with the help of, you can say that these coordinate bonds, water of crystallization is added to the compounds. Now, coming back to the question where the certain terms are added, they are just a reminder, because as we proceed in organic chemistry, there will be many such terms. The purpose of putting up question was that till now you have solved many questions on the molecular formula determination or empirical formula determination. But what happens there? You get to know the percentages of an element. Different elements are there, and you have to, the grams or the percentages of different elements. In this question, what is given to you? Water of crystallization, that means amount of water or mass of water is given. Do you understand the difference between the normal questions and this question?
Yes, ma'am.
So how do you want to solve, or how this question can be solved? Any idea? It is pretty simple, I tell you.
Miss, should we find the like ratio and then convert it into percentage, and then should we go like that?
Yeah, the simple thing is that whatever you were doing till now, it will apply to water also. Instead of atomic mass, what you will take? You will take the molecular mass. Right?
Yes, ma'am.
Any doubts to anyone?
No doubts, ma'am.
Okay. So suppose if somebody said if instead of water, any other molecule, they say, let's say a hypothetical formula AB3 dot NH3. Water of crystallization means a small molecule is present in the cavity. So what we say here is that similarly, any other small molecule, ammonia is considered a small molecule because its atomic molecular mass will be 14 plus 3, making it as 17. So instead of like you have solved the question for water, you must be able to solve a question based on it. If you have ammonia into it. Amrisha and Ananya, is it, everything clear to you? I haven't heard anything from you.
Yes, ma'am.
Yes, ma'am.
Okay. Has anyone already done this type of a question?
Yes, ma'am.
Okay. Now moving on, let's talk about chemical reactions first, then we will go to your, because this is a part of your syllabus. What you have learned, what do you know about a chemical reaction? This experiment, I will also I'll record a video for it and share it with you. It exactly happens like this, that if you heat magnesium ribbon, you get a white powder of magnesium oxide. This is a images clicked while I was performing the certain experiment. So chemical reaction, what is a chemical reaction? This is the definition that when you represent the the participant and the product by their chemical formula and the symbols, and it is balanced. I believe balancing of equation is clear to everyone. Is it or
No.
not? What are the benefits of see, this is the classical definition. See, since it is a part of a syllabus, you just have to learn it and reproduce it as and when asked. Balanced and unbalanced chemical equations must be very clear to all of you. Balancing of equation follows which law? Can somebody quickly tell me?
Law of conservation of mass.
Correct.
Ah,
That can be one of the questions which can be asked in multiple choices. Now, implications, they seem to be pretty obvious, but if you are asked to write, at times we do fumble, right? So that is why I have just put them at one place, that it gives you about all the information about the reactant and product, how many atoms and products, how many atoms or molecules of each of them is participating, how many of them are formed. It does it in terms of number, it does it in terms of mass, because if you know the number, you can always find the mass or volume with the help of mole concept, right? Then similarly, limitations. Do you know the symbol of reversible reaction symbol? Anybody knows? Anybody?
Miss,
Anya?
ma'am,
Yeah.
ma'am, a doubt, ma'am.
Yeah.
Like a chemical equation actually gives you hints about whether it is endothermic or exothermic, because we know that bases don't react until they reach a certain temperature. So How can we consider that they does not tell whether the reaction is endothermic or exothermic?
See, when you dissolve sugar in water,
Yes, ma'am.
can you feel the heat exchange taking place there?
No, ma'am, but okay.
Right, see
But
the.
that is
I'll-
some rare cases. No, ma'am. Most of the time when we carry out chemical equations, we know that we have to do it under some circumstance. So while we write the chemical equations itself, we know what the environment should be. So we would be knowing whether it should be endothermic or exothermic even before writing the equation, no, ma'am.
See, formation of ammonia, I'll explain to you what is the meaning of it. N2 plus 3H2 gives you twice ammonia. This is an equation for the formation of ammonia in laboratory. The
Yes,
sign,
ma'am.
sometimes this sign is drawn by this symbol, but to me, this is more appropriate, right? One is
Okay.
representing the forward and the other one is representing the backward.
Backward.
See, since they are the half reactions, so we should have half arrows, not the full arrows as here, right? For every, believe me, this is a fact, no reaction in this world is going to be a complete reaction. It appears that the reaction is complete, but no reaction is 100% complete, because for every reaction, there is an equal and opposite reaction, right? So that means we can never see if the reversible reaction is taking place, we say reaction is complete, because practically if anything is 90% or above is done, it is said to be a complete reaction. Like when you are cooking food, or if you are preparing Maggi, or you are boiling water to make tea, even before the boiling temperature, if you put sugar, sugar, tea leaves, and milk into it, what will happen? Tea will be formed in both the cases. Let the temperature be 90 or let the temperature be 100. But only by taste you can say this is not tasting good, this is tasting good. But nobody can tell how much percentage of reaction is reversible. How many reactants have been converted into products? Out of the tea grains which you have put inside it, what number is exactly being converted into product, right?
Yes, ma'am.
Similarly, if you do not know the extent of completion of reaction, you can by and large say, I give you an example that if your home is being whitewashed with calcium
Yes, ma'am.
oxide,
Calcium
what
oxide.
happens? It is a reaction is the heat is given out, but you
Yes,
cannot
ma'am.
measure its volume, right?
Okay,
Exothermic,
ma'am.
if we say it's an exothermic, it is exothermic, but it does not mean endothermic is not taking place. Most of the time, we put up a symbol of heat. Have you noticed it? Go back to your 10th class book. Every time, everybody puts a, even for the formation of ammonia, Haber's process, in Haber's process, we put it at definite temperature and pressure. So by and large, it does not decide. Is anybody having any other doubts in it?
Ma'am.
What is a photochemical reaction?
Ma'am, a reaction which takes place under only the influence of light. For example, AgPr decomposes with light to form Ag2 and Pr2.
Correct. Similarly, photosynthesis is a photochemical reaction. It will never tell you whether it is a violent in nature or not. Violent means whether it explodes or not. I think I told you that the teachers do not allow you to do the practicals in your chemistry lab just because of this simple reason. Because reaction of sodium and water is highly exothermic. The students take out sodium, throw it in the sink, and it explodes, right? In no reaction, the last point must be very clear. It is simply written concentrated sodium chloride, concentrated HCl or dilute HCl. But they never say it's a 2 molar, 3 molar until unless we are carrying out the titrations, right? Now moving to the last part, that is
Yes,
stoichiometry.
ma'am.
Stoichiometry to me is an extension of what we do in mole concept. That is why we say stoichio means it helps you in measuring the elements of the compounds which are participating in a reaction, or whenever you have to set up a reaction. Suppose if you have to prepare 2 molar sodium bicarbonate solution, you have to find out the numbers. So the definition of stoichiometry will never be asked. Again, the simple fact is the atom can neither be created nor destroyed. Although we have learned it can be converted into mass and energy are interconvertible in nuclear reaction according to E is equal to mc square, right? So how do we approach, or first of all, whenever you are given a question, we have to follow the certain basic rules, right? Some of you who have practiced more must be very good at solving these questions, but these days or last 3 years, they are not asking you a very difficult question involving 2 or 3 concepts. They are just asking you to do a basic question. So first of all, we must understand how to read this particular equation in terms of mass, volume, and number of particles. This you know or not?
Ma'am, we could use the ratios.
Rest of the class, Ananya, Amrisha, and other students sitting at the center, do you know this or not?
Yes, ma'am.
Okay, let me quickly go through this. See, we have to read this as like this, that 2 moles of potassium chlorate react with, when heated, will produce 2 moles of potassium chloride and 3 moles of oxygen. If I talk in terms of molecular mass, I'll say 2 units of molecular mass of potassium chloride on heating will produce 2 units of molecular mass of KCl and 3 units of oxygen. Similarly, for volumes, I have to read it like this, and then in terms of liter, I have to read it like this, and in terms of numbers, I have to read it like this, right? And then we must understand, I think I have taught you mole concept, that these 4 things are equal to each other. The simplest thing you have to do here is that you have to find that what are these 2 things which I have to relate. We have added, I put it in a reverse order, saying that we have added one more layer to it. You have to have a balanced chemical reaction. Then you have to apply any of the equity or ratio of the mole concept to find the answer. Now, if I ask you this question, I'm not interested in answer. I'm simply interested in your approach. How many moles of KCl will be, or potassium chloride will be formed by the decomposition of 245 grams of potassium chloride? I'm just interested in knowing what are the 2 equities you are going to pick up. Any answers from the class?
Doing 1 minute, miss.
Okay. Okay, you might be stuck up at this point. If you have started calculating, although I have repeatedly told you that I'm not interested into the answer. I'm interested in you to find the way how to reach to answer. It is saying moles of potassium chloride. So I have to take 2 moles from here by the decomposition of 245 grams of potassium chlorate. So what I have to take? I have to take this. Simply equate them and find the answer. Right?
Yes, ma'am.
So if you, does anybody have a doubt in this? See, and Ananya and Amrisha,
No, ma'am,
neither
not
your
specifically discussed.
Okay. No, neither the cameras are open, so I cannot see your responsible. So I'll appreciate if you can open your cameras.
Yes, ma'am, actually my camera isn't working.
So get it prepared then.
Yes, ma'am. Sure.
So this is just, I have listed for the information that stoichiometric problems or the problems based on chemical equation can be of mass-mass relationship, mass-volume relationship, or volume-volume relationship. As you have seen in the slide, all equations are relatable to each other, can be equated to each other. If I have given mass and asked for mass, that is a mass-mass relationship. I have given volume, asked volume, that is a volume-volume relationship. So that classification does not have any meaning. But again, talking to the students these days, it's important to make them aware that it can be asked in MCQ type of a question also, right? Because usually we do not teach them. And do you want to do practice on more on it or not? This was the solution which I have already, see, I also solved it on a piece of a paper like you people do, right? I just ask you a question. Do you want to do more questions or not?
Yes, ma'am.
Okay, I'm not going to do the easier ones. Let's do a different type of a question. So solve this one. How many electrons are present in 1.6 grams of methane? In this section, whatever questions we are doing, they are not a regular book type of a question. They are bit of eye opener or a different type of a question, because I assume all of you have gone through the chapter 1 very well. In your schools, you must be having, you have given your exams last Sunday, I have heard. What was the scores you were having? Or, okay, don't talk about the scores. Let's not do that. In general, how was the paper? Was it a difficult or easy one?
Slightly difficult.
Slightly difficult. Okay. So you wanted an easier question. What is the reason? I think that is Raghav, or who is it who said slightly difficult?
I'm Raghav.
Yeah. So what was difficult in that paper?
Like most of the sums are like most of the sums I didn't know how to like put the sum itself. But I knew like some of the sums.
Okay. So that is the reason we are spending see this chapter, you do any number of questions. I still say you apply the basics as I'm trying to tell you. And of course, there will be certain questions which will be difficult. And paper to me has to be set like that, which elevates you and makes you understand that, okay, you know a lot of things, but not all of the things. So you need to do practice. So we may be discussing the paper in the next class. Coming back to the question, this is a question which you should not be probably finding, or even if I have picked it from the book itself, I have changed either the digits, or there must be a purpose of me putting up this question.
No,
So what is the answer?
I might try to do it. I'm still doing it.
Okay, I'm waiting. I'll wait for 3-4 minutes and then we can discuss the answer or how to get to the answer.
6.02 into 10 power 22.
I didn't get you.
6.02 into 10 power 22.
Okay. Anyone else?
Same answer, ma'am.
Same answer.
Yes, ma'am. Everyone got the same answer.
Everyone. And what about Ananya and Amrisha?
Yes, ma'am.
Both of you got the same answer. But my answer seems to be different. I remember I solved it by the second method. I didn't solve it by first method, but when the question is given to me, I prefer to solve it by second method. I just did it this way. Look at the second method, where I solved it this way, that 16 grams of methane is there because molar mass of methane is 16. So 16 grams means how many methane contains 6.022 into 10 to the power 23 molecule. So 1.6 will contain how many? This much. And one molecule of methane contains 10 electrons. So you have to multiply it by this 10, and that will be the answer. This is one of the ways to solve this. The other one is that first of all, 1.6 moles is given to you. You find moles, that is 0.1 mole, right? 1 mole has this many atoms. So 0.1 will have how many? You do this. And then each one of them, the total number of electrons in methane is 10. So should the answer not be 6.022 into 10 to the power 23? Ananya, can you explain?
Mom, I forgot to multiply the number of atoms.
Tell me, how can it happen? I'm not saying only to you, but the students sitting at the learning room, Ananya, Amrisha, everybody made the same mistake. So Raghav, what is the reason for not getting the correct answer? I will appreciate somebody other than Raghav also explains the reasons.
This is the right answer. 6.022 into 10 power 23.
Yeah, you gave it, but you said 22 or 23.
I'm 22.
So but the correct answer is 23.
No, 0.1 moles into 6.022 into 10 power 23. So 22.
Where will the 10 electrons go, Raghav?
No, 1 mole has 6.022 into 10 power 23.
But the question was for 1.6 gram. It was not 1 mole. It was 0.1 mole.
Ma'am, I got the mistake. It was, we calculated for number of particles, but the question was for number of electrons.
So what is the rule number 1 in the exams? Read the question paper carefully.
Yes, ma'am.
Any other who understood the mistake? I want to hear from rest of the class, students sitting there at Learning Room Center. Amrisha, what was your mistake?
Ma'am, I got 6.022 into 10 to the power 23.
Okay, but you never told me.
And I said I got the answer.
Okay. Yeah, somebody saying something? So I'll appreciate if we can focus on not doing the silly mistakes. Let's do this easy question. Here you have to identify the element. I think there is a mistake. It should be compound, not element.
Yes, ma'am. That's why I was confused.
Yeah, it has to be compound. Otherwise, how can it have carbon and hydrogen? So correct it and then do the question. Compound X has vapor density 15. It contains 20%
Is
hydrogen.
it CH4 methane?
Let's wait for the rest of the class.
Ma'am, CH3.
Okay. See, this question is just very easy. So easy that even I made a mistake in putting the question. Simple that I have just told you the 2 into vapor density is the molecular formula. So it's 30. Right? The molecular mass 30 is for what? Methane or ethane?
Methane.
So that was simple. It is one of the tricky and the difficult questions which should be asked after probably teaching you the hydrocarbon. But the sense of putting this question was here to understand that the various concepts can be also linked. I should have put the word as hydrocarbon into it. Although percentage of carbon and hydrogen is given, that makes the same thing, right? Now, this is a typical stoichiometry question. That your 20 grams of you have to write the equation first. So do as I'm saying, write the chemical equation first. Then apply mole concept. And I have given you the atomic masses. And you should also try to remember some of them at least. Have you written the balanced chemical equation?
I'm writing.
Ananya and Amrisha, have you got the answer?
1 minute.
Yeah, got the equation at least?
I got the equation, ma'am.
Yes, ma'am.
So an answer is still waiting.
Mom, is it 36.5?
Okay, let me show you the answer. It was simple that you have to write the equation. Magnesium, it's an acid-base reaction, right? That is why I put it up here. I haven't taken a very difficult example here. Magnesium oxide and HCl will react to give you magnesium chloride and water. Then you have to simply apply the unitary method. 40 gram gives 73. So 20 will give half of it. And I have purposely put a strikeout symbol on the grams so that it reminds you, like physics, you have to be careful about the numbers, right? Sorry, unit, not numbers, units. Numbers can be correct, but the units, and that is a better way of solving a question, that whenever you are solving it, not for this particular chapter, but when you are doing for say thermodynamics or chemical kinetics in class 12, then you should put up the units also, so as to get the correct answer, right? So this is the most awaited thing which you were asking for so much a long time. Just tell me that in what depth your school teacher has taught you. Ananya, is it not taught in your school?
No, Mom, they directly started the second chapter.
They haven't. Okay. Amrisha?
No.
This section is taught in your school?
Which section?
The concentration terms. I think in the last class, everybody was asking for molarity and molality. Or am I confused?
Molarity they have like taught in our school.
Okay.
Ma'am, can I explain that formality?
I can tell you everything. Formality is when formula mass is dissolved in water. Like sodium chloride exists in crystal state. I'll draw that for you.
I'm going to repeat.
I'm telling you. Let me draw this, then it will be clear what is a formality. So this is a cubic structure of sodium chloride. Sodium chloride does not exist alone. See, here you have a sodium cation, and at some other places, there will be let's say there are two, although the ratio is not this, but assumingly this is a chloride and this is a chloride ion. So one such unit cell will have many sodium chloride. Or we say for crystalline compounds, the formula is NaCl. So when 1 mole is dissolved in 1 liter, a formal solution is prepared. Molarity is 1 mole dissolved in 1 liter, 1 molar solution, right? Number of moles dissolved per liter is molarity. Number of formula units dissolved per liter is formality. Who asked me this question? Is it answered or not?
Yes, ma'am, it is answered. No,
Okay. Yeah, please carry on. Was that Raghu saying something? Please say.
Ma'am, I wasn't saying anything.
Okay. Anybody else was saying something in the classroom?
No, ma'am, you asked my name.
Okay.
So I was about to say my name.
So I'll tell you the see, since it is the students sitting at Learning Room Center, molarity and molality are taught in your school or not?
Yes, ma'am.
I
Yes,
didn't
ma'am.
hear you.
Yes, ma'am.
Okay. So if they have taught, let us do everything one by one in the formula, right? Beginning with what is a mass percentage. This you have done in class 9th. Is it clear or it is still not clear? What is a mass percentage?
Clear, ma'am.
Volume percentage?
Clear, ma'am.
Mass by volume?
Yes, ma'am.
ppm?
No, ma'am. A girl in our class wants parts per million to be explained.
What is the name of that girl?
Meghana.
Okay. See, mass percentage, we have done it in the lower classes. It is represented by W by W. Please, whenever you buy a syrup of a medicine, especially the cough syrup, just see W by W is written or W by V is written or V by V is written. That means the solute and solvent are in which physical state. Have you ever noticed that the ghee label, do you understand what is ghee? Clarified butter probably. Look at the
Not-
label of,
Ma'am, parts per million, ppm.
oh, I know, see, this is something important.
Okay, ma'am. Okay.
I will do that ppm in detail, that's not an issue. See, whenever you purchase clarified butter or ghee, look at the label very carefully. We pay the money for 1 liter, but we get 900 grams. Make it a habit and it will be helping you somewhere or the other. V by V is clear that solute and solvent both are measured in terms of a volume, that is liters, like that. W by V means solute is in solid form, whereas solvent is in liquid state. ppm means that it is multiplied by 10 out of a million. How many particles are there? If you read any news article, look for the respiratory index, look for the gases present in the environment. Every time they tell you how much CO2 ppm, sulfur dioxide ppm, that is, they tell you out of 1 million, how many particles of that particular gas or a pollution causing substance are present. Is it clear? Simply, we talk in terms of numbers. Like in case of most, sometimes we talk about in mass, volume, and here we are talking in terms of number. Is it clear to Meghna now?
Yes, ma'am.
Just be louder, Meghna.
Yes, ma'am.
It's too loud. Now talking about the molarity and molality, which is the major concern of the entire batch, isn't it? So who knows the difference between molarity and molality? Anybody who knows? No one. So there are two nearly similar terms which are frequently used to express the concentration of solution. One is called as molarity.
Molarity and modality.
Yeah, it is represented by capital M. And we have a small m, and it is called as molality. The formula of molarity is moles of solute upon volume of solution in liters. Whereas molality is, it has the same numerator, which is moles of solute, but the denominator is different. It is mass of solvent in kg, right? Is the formula clear to everyone?
Yes, ma'am.
Okay. Now, it is simple substitution. How will you find the moles of a solute? Moles can be calculated by mass
My mass percent.
by molecular mass. Now, to understand the difference and the importance of both the terms, let us do one calculation. I say that we have a solution in which four grams of NaOH is dissolved in 1 liter of water. I just want the formula. Remember, I am not here to ask for a calculation. What is the value of molarity and what is the value of molality? We are assuming that density and mass are equal. For solids, we say 1 gram is equal to 1 density and mass are equal, right? Say if it is a water, 18 gram water is equal to 18 ml of water. What is the molecular mass of sodium hydroxide quickly? The first step is to find the molecular mass of NaOH. If you do not know, I will give you the atomic mass of sodium is 23,
40.
oxygen 16,
40, ma'am.
and 40, right? So write the expression. I'm giving you 3 more minutes to do so. If you are done before that, just let me know.
molarity is 0.1 in the case.
I said I'm not interested in the answer. I'm interested in the expression only. Because the key to solving the question of molarity and molality correctly lies in substituting the correct values. Amrisha, what is your answer? Have you found the expression for molarity or molality?
Molarity is 0.1.
And what about molality? Ananya, what is your response?
I'm not yet done, 1 second.
Okay. At the center, how many of you are able to do it?
Getting a different answer.
Okay. Everybody solved their Raghav?
I'm getting 0.001.
I again say, read the question paper carefully. I said, I'm not interested in answer. I'm interested in expression. What are the values? I'm repeating myself, giving you 2 more minutes. What are the values which you will be substituting? Say for moles of solute, you will putting 8/93. Volume of solution will be 103. I'm interested in those numbers. Formula is given to you. I'm interested in numbers, not in the exact answer which is formed after solving them.
Raghav is getting 36.5.
How should I tell all of you that I'm not interested in numbers? See, my expectation was what will be the moles of solute? How will you get the moles of solute? What will be the denominator and numerator for finding the moles of solute? Quickly. Don't tell me the calculation. Give me the numbers. Mole has told you mass upon molecular mass. What is the mass of solute I have given to you? 4. And the molecular mass of it is 40. Is it clear to everyone or how you have found the moles? Has anyone used any other formula?
Ma'am.
Hmm?
No other formula was used, ma'am.
Okay, then same thing will be written in the numerator here. But what about the denominator? Mass of solvent in kg. I have given you how much water? 1 liter. Density
1000.
of water is 1. So the 1 liter I have given. So answer will be simply, I was interested in knowing 4 by 40. Right?
0.1.
Whatever it may come out. Now what will be the denominator of it? I have said volume of solution in liters. That means that you have to put the volume of solute plus solvent. How many of you have done this?
Ma'am, I got the answer is 0.1 for both cases.
Yeah, because
told-
you have taken, yeah, please say.
0.1 m.
It
And
should
small
not
m.
be 0.1 in both cases. Otherwise, are we the fools or the scientists are fools that they are giving you two different formulas? They are wanting something else. See, solute and solvent, that means what we should put up here. Solvent is 1 liter, it is clear. It has to has a something to be added, right? Solvent 1 is clear. What about solute? 4 grams. If you convert it into kgs, or sorry, liters, what will happen? You have to divide it by thousands. And if you add both of them, then you will get the denominator. Is it clear to everyone or not? Raghav, is it making sense or not?
Yes, ma'am, it's making sense, ma'am.
Then if the formula is written, if I can ask the class, if the formula is written in front of you, why we have not substituted the values like this? Since last 10 minutes, I was asking only to you to substitute the values, because I know you are very good at calculation, probably more than better than me, right? But if you do not substitute the correct values, you are of course going to get the same answer. The terms are clear: volume of solution in liter and mass of solvent in kg, right? Now, the second question comes that which is, by looking at this data, for the same solution, which value will be greater, capital M or small m? Now, if I permit you to solve this question now, which will be a which will have a bigger number, molarity or molality?
Ma'am, molarity. Yeah,
Think twice before you speak. I'm not saying to the student or to Raghav, but I'm saying to everyone.
Okay, ma'am.
Will it be there are two things, only molarity or molality, right? If one says molarity, other says molality, only one can be correct. See, mathematical
ma'am.
mathematical expression is in front of you, which is having a lower, smaller denominator. Molarity or molality? I didn't get you. Your voice was just disrupted.
Molality, ma'am.
Molality. So that means if same number is to be divided by different denominators, I think you can get the answer now. That this is having a smaller denominator, so that the value will be more, isn't it? See, in case of molarity, I have to divide X by 4/40 plus a very small number, right? In case of molarity, I have to divide it by only, sorry, I think I have written incorrect. In case of molarity, I have to divide 4/40 upon 1 plus a very small thing, right? 0.004. Whereas in this case, you have to divide 4/40 only by 1. So which is going to have a bit more value? Ananya, which will be having a higher value? Raghav, where will you put your money for higher value? Molarity or molality?
I don't molality.
Molality, because denominator is a smaller. This is a, I think it should be clear to everyone now. Now, the other question is, see, the purpose of asking this question again is that if I say that there are two values, let's say one is, don't think that the difference will be very high. If one value is 1.02 and the other value will be 0.98 or 99 or still smaller. So if you are asked to make a choice, again, remember they are focusing on the practical aspects, or they don't want you to do the calculations. So the lower value will be of what and higher value will be of what. On that basis, you are to be judged on molarity and molality. Now, if I change the temperature for the same data, out of molarity and molality, which is temperature independent?
Molarity is temperature independent because molality, it has volume. So due to temperature, the volume might change.
I think you have said the reverse. Your idea is clear. One is having molarity is having volume in denominator, and molality is having mass in denominator.
Yes, ma'am.
But I think I might have heard wrong then. That
I told molality first and molarity second. My voice is just
okay.
done.
Yeah, I agree. See, mass will never change with temperature, right? So since mass is constant, it will not change. If I measure it at 100 degrees centigrade or 50 degrees centigrade, its value will be constant. So molality will be temperature independent. And the last question for the day, which is more practical to deal with. So which can be easily done or which can be easily found in case of solutions.
Molality only, ma'am, because mass is there and it is the most convenient unit to calculate as well. And taking that it is independent of temperature, it is more convenient to calculate.
See, according to the observations, it is we are not going by the precision. We are just talking about ease to work, right? If you understand, I'm trying to give you an example, like sodium chloride, what we eat, and sodium chloride in laboratory chemical. It certainly does have certain impurities and it is cheaper. At the same time, we know it will not give you the perfect results, right? But when we are taking sodium chloride as food, we do not compromise. It is expensive as compared to it, and it does not have any impurities. So when the question is which is easier to work, the answer has to be molarity. Why? Because we are talking about the solvent. Most of these solvents are in gaseous or a liquid state, right? Solvents are mostly liquids. So it's easier to measure their volumes, right? Is it clear?
Clear, ma'am.
So therefore, if I ask you, okay, what is easy to work with, or which is more practical or more convenient to do in laboratory, if you are asked to choose between finding molarity or molality of the solution, molarity, as I told you, the value will differ only at the second place of the decimal, not even the first place, right? So it will differ there, but you will be able to do it or perform it in a lesser amount of time. So with this, I have tried to cover all the aspects of the chapter which are stated in your syllabus with a different point of view, which is not usually taught, since you have already done the class chapter 1 in a school as at your own and given the test also. What else you want me to pick up in this chapter? Amrisha, is there anything which you have a doubt in this chapter or needs to be taught again?
No, ma'am.
And the students at the learning center?
Oh, ma'am.
So molarity is done for you. Believe me, molarity, if you start doing questions seriously on it, it will take minimum of a 3-hour class. So since what is the level of molarity and molality taught to you in your schools? Raghav, I want to hear from you.
Ma'am.
That
Ma'am, I didn't hear
molarity,
it.
okay, molarity and molality is taught in your school. You're asking me to teach you. I have taught you. Are your all the doubts resolved now?
Yes, ma'am.
Have you done the questions of molarity and molality?
Yes,
Questions-
ma'am.
All questions done.
Yes, ma'am. Others also have doubts.
Others also
No,
have?
ma'am, no doubts. No doubts, ma'am.
Okay, so should I give you a test again on the next before next class on molarity,
yes,
molality?
Yes, ma'am.
Yes, ma'am.
Okay. I'll just discuss I will discuss and then give you that. If not, because the institute follows a certain schedule, I may probably give you certain questions for homework and then that we can discuss, right? So see you in the next class where we will begin the chapter 2.
Thank you, ma'am.
Welcome.